experiments to look at the extreme environments, you know, in space, so like the moon, Mars, and yeah.
Okay, cool.
All right.
So my name is Anna Ross, and I'm one of the astronomers here at the Royal Observatory. I have come straight from studying. I did my undergraduate degree in astrophysics a few years ago, and after that I did a master's in sort of space engineering, so hopefully more applicable to the architecture side of things, which is why you're particularly talking to me.
Yeah.
So when you're looking at other planets and space in general, the main things you want to be concerned with is obviously temperature is a major factor. So obviously the general trend is the further you get from the sun, the colder it gets. So Mars is a lot colder than the Earth. Its average temperatures are like minus 60 degrees. Another thing that affects temperature is how much atmosphere a planet has. So again, Mars has quite a thin atmosphere, so it doesn't retain heat as well, so another reason why it's colder. The Moon also has basically no atmosphere at all, so even though it's kind of the same distance from the Sun as the Earth, it can't maintain its temperature all the way around, it has no way of keeping that heat in, so very cold at night, very hot during the day. I believe it goes down to about minus 127, sort of nearer the equator, and up to 173 degrees during the day. There are places on the Moon that get a lot colder because there's sort of permanently shadowed regions that never see the sun, such as the poles and some craters that have like high ridges and deep shadows. So lots of very cold places on the Moon, but also very hot. So yeah, temperature is a big one. Other things to be concerned with is radiation. So out in space, there's two main types of radiation: radiation from the sun and background cosmic radiation. So on Earth, we're protected from solar radiation by our magnetic field. Mars and the Moon are both very similar in that they don't really have a magnetic field, so nothing to protect from any of that. If you're looking in space to put a spaceship or anything out there, solar radiation is quite easy to protect from just by sort of normal spaceship materials, nothing too extreme, just sort of metals, that kind of thing. But galactic radiation, cosmic radiation, is more of an issue. Our atmosphere is the one that protects us here on Earth from that. But again, as I said before, the Moon and Mars don't really have any atmosphere, or much thinner, and that's a lot harder to protect from. Mainly because the way it works is that when it hits a substance, that radiation, it kind of knocks into the atoms that make up that substance and put out secondary radiation, and that is the radiation that is really dangerous, particularly for astronauts, because if that radiation hits your skin, then it's kind of not very good to sort of have secondary radiation going through your body. One of the big causes of cancer in astronauts, things like that. So that's sort of an area that is less well known as how to protect from that. So the sort of proposed solutions at the moment are really thick shielding, which is obviously not ideal, especially if you're going off to other planets, trying to launch large amounts of material. You want kind of as light a load as you can to launch away. And there are some sort of technologies being looked at into sort of better materials that are thinner, but as far as I'm aware, at the moment, there's no sort of ideal solution to that. So yeah, those are some of the things. Another thing would be something called MMODs, which are micro-meteoroids and orbital decay. So that's sort of just things flying around in space, like little asteroids, little meteoroids, all those kind of things. Again, our atmosphere on Earth protects us, but the less atmosphere you have, the more you're going to be impacted. The Moon is so obvious of an example of somewhere, because obviously you can see all the craters, even from Earth with your eyes. You can see just how many craters are all over the surface, so that is a big problem. Gravity as well, I guess. So we have evolved as humans for our Earth-like gravity. Other planets, depending on how big they are, smaller planets have less gravity, and the Moon is even smaller again, so that's about 17% of the gravity. The more time you're in microgravity, the weaker your muscles get. That's why astronauts in space have to exercise for at least an hour every day, like very intensely. And even then, as soon as they come back to Earth, they can't walk because they can't even just like stand up again. So yeah, that's quite a big problem. So I guess the main lifestyle change would be the amount of exercise you have to do. At the moment, because we only have regular astronauts in Earth orbit, it's not as different because it's still near to the Earth. We've got a lot of protection from some things because, well, we're at the right temperature and all these sort of things. As we go further away, there'll be sort of more things to deal with. It's quite likely that if we have massive amounts of solar radiation, because the sun goes through solar cycles, so sometimes it'll be really active and a lot of that radiation will be going. You may need to sort of build storm shelters and stuff sort of to go and hide into for those times when it's particularly bad. From an astronomy point of view, the best thing that we can look at is actually Venus. So Venus has like a really thick atmosphere that is mostly made of carbon dioxide, and because of that it has a runaway greenhouse effect, much like we think may happen on Earth. So we do think that maybe a few billion years ago Venus was much more similar to Earth. It even had perhaps it might have had water and stuff like that. Obviously it being closer to the sun anyway, I think we don't think it ever had actual ice caps that would melt to increase the amount of water, but instead it heated up and then those oceans evaporated. So not 100% the same, but sort of the most equivalent really that we have planet-wise to look at. We haven't really done successful missions to Venus, so I believe the longest lasting probe that ever landed on the surface of Venus only lasted for like 127 minutes before it was completely destroyed. But there's other things in Venus's atmosphere that could have done that, not just sort of the kind of climate change aspects that we're going to have on Earth. So Venus has sort of a layer of sulfuric acid in the atmosphere, so acid rain will destroy it. There's a lot of pressure because it's extremely thick atmosphere. Sort of standing on the surface is the same as receiving about the same pressure as if you were 900 meters underwater. Basically, just don't visit Venus. It's not nice at all. But yeah, temperatures are very hot indeed. I think the average surface temperature is like 462 degrees Celsius, so very hot. Yeah, so naturally it would have been hotter, but that runaway greenhouse effect is what may happen on Earth and make it perhaps not quite that hot because it's a bit further, but yeah, the thick atmospheres keep in all that heat and make it hotter and hotter. In terms of measuring temperatures on other planets, we use something called a pyrometer, and what that does is it measures the amount of infrared radiation that you get from a planet, because that's how you sort of see heat, if that makes sense. It's a different kind of light and shows how the heat is being perceived. So you can just measure the amount of infrared radiation a planet is emitting, and there's sort of some equations that you can use to work backwards and work out what temperature that corresponds to. In terms of chemicals in the atmospheres of planets, or if they have an atmosphere at all, we use spectrometers. So they look at the full rainbow of colours that you receive from a planet. They sort of split it up into that rainbow, and then there's a couple of different kinds. It's either an emission or absorption spectra. They're sort of the opposite. If it was an emission spectra, then you'd see lots of dark lines where the colours were missing, and that meant that a particular element was absorbing those particular wavelengths of light. And each element of the periodic table has a different sort of fingerprint, if you will, so it absorbs different places, so you can tell what elements are in that atmosphere. So for sort of general information about the climate of planets, I'd always recommend the NASA website. That's probably the most up-to-date, the most easy to use. ESA has one too.
That's great. Thank you very much.
That's okay. I hope I answered your questions okay.